Hello class, in today's assignment you are going to do your own creative switch plate design. The switch plate can be either made out or to be ornamental, what means with some ornamental graphical object of your interest in a shape, let's say whatever, donkey head, dinosaur foot, be it what it may, some logos or so, or it can be functional, like for example to have, besides being the wall switch plate, to maybe have like a bottle opener or a letter opener or a keychain holder or something like that. So we are going to design the switch plate to be able to fit the standard IAC switch, and I provided to you at the end of the assignment the dimensional description, so essentially the napkin sketch of the standard switch plate. The dimensions are in inches. This hole is countersunk hole, countersunk through hole for the number 6 screw. So don't worry about dimension. If you use the number 6 screw, 632 is what is used as a standard screw to mount the switch, to mount the rocker switch to a switch plate. So just use the standard number 6 countersunk, countersunk through hole. This is the standard dimension. Your switch plate may be of a different dimensions, however, the size of the cut for the switch and positions and relative size of the screws to mount the switch can't change. Also, be aware that the switch plates need to be hollowed from inside, otherwise the switch will not fit. So the idea here is that you will do also some design brief, as described here, and to come up with a couple of ideas, what you are based on your interests, and then to choose the best idea that you want to convert into an object. We are going to use here extensively the sketch image option in a SolidWorks, because what we are going to do, we are going to either make some hand drawing or find some image like a pictogram, some image that you want to convert into the features of the switch plate from the internet, download it, and then import into the SolidWorks sketch, scale it properly, and build the switch plate around it. And in my case, I'm going to go directly to building a switch plate. I love dinosaurs, and I'm going to do the dinosaur footprint plate. And here is like something that I found on Shutterstock, on the stock images, different dinosaur footprint plate, and something that will have a proportion of the switch of the standard switch plate will be some footprint, for example, like that here. I'm going to save this image, and I'm going to use it now in a SolidWorks. So let's start SolidWorks, and let's start the new file, new part file, and material, as we are going to 3D print this stuff, will be an ABS. Material will be a plastics ABS, as we are going to 3D print the switch plate out of the ABS plastics. First thing that we are going to do, we are going to start a new sketch. Then going to a tools, sketch tools, sketch picture, and I'm going to insert dinosaur footprints. However, they are not scaled. For now, I will leave it in there. I'm going now to make my outer boundary of the switch plate, and I will make this into the for construction line rectangle, and that rectangle is going to be a 4.495 by 2.745. 4.495 by 2.75. Now, what I can do, I can edit my sketch picture And I'm going to scale this sketch picture down. First, I'm going to move it to put my pawn of interest. And let's say that I want to build the most standard dinosaur pawn. And I'm going to start scaling it down until I have a pawn which approximately fit my plate. Scale it more, as I want to have a pawn as an ornamental symbol on a plate. Need to scale it down more. Now, what I'm going to do here, I'm going also to use the transparency because I need this picture to be a little bit transparent so that I can edit my plate. And to make it transparent, I'm going to click on a from file or full image. And I can put it like about 70% transparent. That will work fine for me today. Okay, so again, if I edit the sketch picture, I can actually center it nicely. So one option is to have the pawn, the dinosaur pawn, embedded onto the switch plate. The other option is to have a dinosaur pawn to actually be larger than that switch plate size. And for itself to become a switch plate. But however, it will be maybe too large. So let's check that option. If I make the dinosaur paw to be large, it still will not cover. It will be too large of the object. And will still not cover the standard wall hole. So essentially, because the proportions will not work and it will be a ginormic object, I'm going to scale it down and I'm going to put it again as an insert here. I'm going to make vertical center line so that I'm able to kind of center it, and the horizontal center line to make the position of that picture. Here is the center. And I'm going to pull it a little bit below so that actually the switch is going through the middle finger of the dinosaur. Okay, so this will be my general layout for the switch plate. I'm going back now to my design here section. I'm going to start this project by making an extrusion of the thickness 0.209 and start carving the objects inside. So I'm going to close this sketch and I will form another sketch. On the front plane again. And I'm going to recycle my rectangle by converting the entities. The middle two are going to be for construction. And I'm also now going to check for my hole, which is 0.963 by 0.423 centered. 0.963. And I'm going to use the centered rectangle. Vertical dimension 0.963 horizontal. Point 423 and the center. Okay, so now I can go back to my sketch one. I can move that. See where I want it. Maybe I want it to be like this, to be actually in the path, in his finger. So it will be a finger that the dinosaur is going to bend. Two 2.75 or 2.745. Okay. Five and 4.5. Okay. Now we are going to extrude this for a thickness for 0.209 as a single extrusion. For the thickness of 0.209. Okay. And again, I'm going to play a little bit with my sketch picture. Okay, now what I'm going to do here, I'm going to continue building this switch plate. I'm going to place the two number 6 holes at 2.375 centered. So 2.375 centered will be the number 6 countersunk holes. So if I place a hole wizard and I choose the countersunk and it is a ANSI inch and I go size number 6 and fit normal and through all condition, now I can place the holes here. Going to be sure that I specify the hole to be coincidental with my line. I'm going to specify the distances between the hole to be 2.375. And I'm going to center it by specifying distance from this is equal 2.375 divided by 2. So here are my holes. Now I'm going to do the fillets of the sides and I'm going to do the shell. And after I'm done with the shell, I'm going to build the ornamental feature of dinosaur paw. Because if I do it otherwise, it will not work, because the shell will try also to shell the dinosaur paw, and that will lead to a shell collapse because the thickness, the minimum radius, will not be able to be enforced. Also, one other thing that I may want to do here, I'm going to actually introduce a 5 degrees of draft, as in the next exercise we are going also to make a mold. And actually, in that particular arrangement, it should be a Now, we are going to shell it and to leave the thickness of 0.09. However, that we will do after the fillets. Let's do the fillets. Items to fillet. I will go with the round fillet. The side. Top. And the sides. Let's see if it will work as a full round fillet. Well, unfortunately, fillet is the most troublesome command in SolidWorks, so we will need to do this maybe as a two-phase fillet. Okay, well, in that case, we are just going R.209. And we are going to just choose face. And here it is. It is filleted all over the face. Now, the next step that I'm going to do, I'm going to shell it from this side. And to shell it, I will go to a shell, and thickness of the shell will be 0.09. And the shell to remove is this one here. And we also don't need this piece here, so to get rid of this, what we need to do, we will place a sketch. We are going to convert the outside edges, and actually we can just convert the just convert up to here, so we can just make a one larger rectangle, centered rectangle, to eliminate that feature. In order to keep everything parametric, I will constrain it. And extrude it down to the next. Extrude cut up to next. Or up to surface. And here it is. Now, structure of my plate is clean. So I can insert my switch and it will stay inside. Now I need to continue. This is essentially the structure of the plate. I will call this my dino switch plate. And I will save it in my directory for the ENGT131, and I will call here switch plates. Actually, I want you to say with your last name first, so that we know what it is, as you are giving me. As you can see, we again need to edit that sketch picture. Just slightly to scale it down. was again what happened because of the fillet. It was again outside of the scope. If I look straight to plane, you can actually see that I still need a little bit of scale up, of scale down, pardon. Click on a sketch, double click on a sketch, on the sketch picture. Okay, and this will avoid the fillet. So, except that we also need to look straight to it. Nicely centered. All right, so here is my dinosaur switch plate outline. Now, I need to build that piece which I have just created. And ornamental, actually I'm going to bring this, I'm going to put this as a recess, like that the dinosaur stepped on my wall and that it cut a little bit of the, and that I got some cut of his legs. So it will be actually extruded cut with a draft. So I'm going to sketch on the top plane, on the top face of my switch, and I'm just going to trace half of the dino leg with a spline tool. And we will kind of also help that spline to get a little bit better. And we are just going to do a half. Why we are going to do the half? Because we are going to mirror the rest of it. And now I can just move those points to make it to look smoother. Okay. Now I'm going to mirror entities and it is to mirror and copy and mirror about my center line, what means that I first need to create a center line for this sketch. Now we are going to mirror these entities. And here is my center. Here is my dinosaur footprint that I'm going to take out of my switch plate. Now, one of the things that I may have a problem is with this hole. So actually I will go to my hole wizard, edit my hole wizard and positions, and I'm going to delete the other hole, because what may happen actually, as I do the cut, I will need to do that hole at the bottom surface. Another modification that I'm going to make is I'm going to do the cut for the 50 thousandths. I'm going to put 259 for the extrusion. So I will make it just slightly thicker so that there is actually a place of what to cut. And the shell, when I shell it out, I'm going to make 0.09 plus 0.05. Now, I'm going to do the extrude cut. The direction is down, and the thickness is going to be 0.05. And it will have a draft of 15 degrees. And here is my dinosaur step. I'm also going to put a fillet there if it can add it. That will be a very small 0.025. However, it will help that this piece stabilized itself. Let's see if it will work. Okay. Actually good. And another fillet at the top. Now I need to place another through hole. I'm going to place another hole here with my hole wizard, which is already set, and I'm just going to place a position on my newly created surface. Going to click on my hole and on the line. I'm going to make those two coincident. And I'm going to distance the hole and the distance between the two holes are 2.375. Between the two hole centers is 2.375, and that is the projected distance. And that have placed the hole in the palm of this dinosaur. And this complete my switch plate production. Now I can make this sketch invisible, hide, and here is my dinosaur switch plate. What else I can do if I want to have an embossment here for the hole? I can build that boss back because it disappeared because of the order of holes and shells. So what we can do to make this one to be formed again is just simply evaluate. Let's see what is the diameter of this one. It's 0.43 inches. So all what we have to do is to sketch on this surface circle. On the inner surface we are going to sketch a circle. If I click on this circle and if I click on the outer radius, I'm going to say that those two are equal. And I'm going to convert the inner hole, convert entities, close it. And now I'm going to extrude up to this feature, extruded boss. And the end condition will be up to surface, and the surface will be the other boss. And we have recreated a little boss which will help us to make this switch plate more stable. This now have completely completed creation of my switch plate. And to fabricate this switch plate, I will use the 3D printer. So in order to fabricate it, I'm first going to save it as a SolidWorks file. And then I'm going to save as STL file because the 3D printers accept, the 3D printer softwares in general accept STL files. So I'm going to go to the STL and I'm going to click on the option. And I can go with a fine, however, the angular tolerances are not good. So I will go to a custom and I will go to an angular tolerance of about 2 degrees and deviation is more than a fine. Click OK and click Save. And here is my switch plate STL file. And I'm now ready to make it into a 3D print. So to make a 3D print, you will use whatever software you use for your 3D printer. In the case of the Airwolf 3D Axiom machine, which we have here, I will use the Apex. So I will start the 3D printing software. And we are going to choose our switch plate. We are first going to choose material. Because this switch plate is hollowed in the back, I'm going to use the soluble support, ABS with hydrophile soluble support. Quality can be precise. And now I'm going to load the file. And that file is somewhere here, switch plates, Mičić Dino switch plate. Now, I want to orient a file in a way that the visible parts are outside, that they are not covered with a soluble support. So I will click on the rotate icon and I'm going to flip this thing for 180 degree. And I'm going to create G-code. I'm going to create a toolpath, and to print this switch plate, it will take about 4 hours and 15 minutes. So if I go save toolpath, I can save toolpath to my Mičić Dino switch plate as a G-code, and then I will copy it to the 3D print, to the SD card for a 3D printer. I can check the tools paths, how it is going to be printed. If I click on a view mode and layer, and we see that there is a total of only 34 layers, and we can see that it starts by building the soluble support, and then the yellow item is actually material of the plate itself, material of the part. The blue items are soluble support. And then the solid blue line is the rapid traverse, the travel of the 3D printing head. And this concludes now my demonstration. Now it's your turn to make your oven switch plates. Let's 3D print them.